So this intro was hard for me because I promised Amanda I wouldn't cry, and then I didn't want to make her cry. So I'm going to try to keep professional as much as humanly possible. Amanda Casari is an engineer and researcher who has worked in many technical and social technical disciplines for over 20 years, including developer relations, product management, data science, and underwater robotics. Amanda was named external faculty member of the Vermont Complex Systems Center in 2021 and co-authored Featured Engineering for Machine Learning Principles and Techniques for Data Science for O'Reilly. Amanda is persistently fascinated by complexity, the differences between the systems we aim to create and the ones that merge roller derby and pie. Who doesn't love pie? I met her a few years ago at another conference, and I remember her being so welcoming and so lovely. And ever since then, I was like, if I ever grow up, I want to be exactly like Amanda, and I can't wait for her to join the stage and give her talk. So please give a very warm welcome to Amanda.
Thank you. Whew. Thank you, Elaine. Happy Sunday morning. I am deeply impressed that everyone who is here, so thank you very much. I would like to take some time this morning to talk about hope. In case you missed it, the last few years have been a bit of a whirlwind. Like every other tornado, this was not the kind of uplift many of us truly wanted. Being in the US, one of the biggest impacts of the events of 2025, the continued impact and cascading events of 2026, is that we can see already here who is able to be here with us this weekend, and that there are people who we know who are glaringly unable to be here. I want to acknowledge that the global Python community, the people that we talk to, work with, care about, depend on, need, and want, these people are not all here today with us in this room. And I also want us all to acknowledge that even despite the best effort, the thousands of hours of community building, the coordination from literally decades of work, and so many thoughtful people, we do not yet have a single geographic space where everyone in Python feels both welcome and safe. And even so, I still think this work is worthwhile. I still believe in the power of community, of presence, of coming together to understand different ideas and opinions. And I still believe that we will always be more together than we could ever be apart. I'll take the applause. Yeah, thank you. You won't interrupt me. Please keep it coming. I am fortunate enough to be reminded of this lesson every year on a very tightly, regularly scheduled cadence when the amazing people from my team kick off the annual cycle of Google Summer of Code. For those of you unfamiliar with this program, Google Summer of Code is the longest-running mentorship program in open source at a global scale. We're now in our 22nd year. We work directly to support the mentorship. This year, we'll be working to directly support the mentorship of over 1,100 contributors, paired with over 2,000 mentors and org admins from 183 open source organizations, including the Python Software Foundation and the Django Software Foundation. And over these past 22 years, the application process and the program cadence has continued to evolve. We've made changes to reflect platforms that communities work in. We've designed program steps to demonstrate basic developer tooling knowledge to ensure that applicants are starting from the right skill level to be successful. And it should be no surprise to anyone here, especially to the Google Summer of Code mentors and org admins, we are also facing the same challenges of every other open source maintainer and project leader with an open issue tracker. It should not be a surprise to anyone in this room that unfortunately, the quality of the proposals have not scaled linearly with the quantity. And we know that where we are now, specifically how we work in the open now, it cannot stay the same. So we've been working together with our community to understand what it needs to be different. What do we keep? And then how quickly should we be adjusting? One of the best ways we get this opportunity is at the annual Mentor Summit. So every year as part of the program, we provide travel stipends from representatives for the organizations to bring people together for a 3-day unconference and learn from each other where we are and where we want to go next. I was fortunate enough to attend last year's Google Summer of Code Mentor Summit, which is where I found a very clever sticker on a sticker table that introduced me to the Artemis project. For those of you equally uninitiated, the Artemis project is a real-time operating system for Earth and space. Artem stands for Real-Time Executive for Multiprocessor Systems. It's used in spaceflight, medical, networking, and many other embedded devices. And I will tell you, conceptually, I know that open source runs the world, much of the world. And even knowing this, I'm still in awe learning about a new project that's been developing for 38 years, is still running on multiple human design systems exploring out of our world, including the Mars Reconnaissance Orbiter, which was launched in 2005 and is still orbiting around Mars. As of today, the MRO has been active at Mars for 7,175 sols, or 20 years, 2 months, and 7 days. So I hear a lot of SREs talking about uptime, but not at this level. And it was when I was reading about the Artemis project's docs and site, as one does, right? You get excited about something, you go to the docs page, you look at the site, you want to see what they're working on. I learned that NASA had a special outreach program as part of the Artemis II launch. For a limited time, you were able to launch your name around the moon by sending in a form. And these submissions were uploaded to an SD card and shipped in the Artemis II launch. Of course, being a huge nerd, I absolutely filled out this form, not once, but twice. But it wasn't my name that I wanted to send around the moon and beyond. It was both of my kids. Thanks. So SD cards weigh between 0.25 and 2 grams, not the NASA kind, depending on the size. And these kinds of grams add up when you account for everything you need to survive in space. And in the world that 2026 continues to be, it's still meaningful to me that in all the software and the hardware and the fuel, there are tiny little bits shaped in the binary form of my kids' names that were carried through space with 4 humans farther than anyone has ever traveled before. And my kids don't know yet what it took to make that happen. All of the people who have been working in technology for decades and lifetimes, and even after all these years of my own work, I'm still wrapping my head around it. We've come so far as humanity, and it can be so easy to forget this when the crush of the news cycle stares at you every single day. And it can be hard to see beyond your desk at what is possible when you can look up, look away, and when we can move collectively towards a future that didn't exist before we imagined it together. But I think this is still possible. Just like it was possible to send 4 humans and my kids' names further than ever before around our only moon. So today, I want to talk about how to keep moving forward and my hope that we can all find space again. So to start, let's talk about the Apollo Guidance Computer. This is the digital computer produced for the Apollo program that provides computation and electronic interfaces for guidance, navigation, and control of the Apollo command module on the Apollo lunar module. In earlier manned spaceflight with the Gemini programs, astronauts flew manually with control sticks, similar to what they were used to from their experience as military test pilots. And as the complexity of the flights increased and the missions changed, the Apollo systems changed to match the problem space. They combined automated systems and worked together across multiple design decisions to understand where and how the astronauts would and should have control. And if you're familiar with the different dynamics between design teams and engineering teams and researchers and users, you will not be surprised to know that how this control was decided depends on who is telling the story. But ultimately, when landing the moon, the Apollo lunar modules completed their landing by human-controlled spaceflight, not on autopilot mode. And as someone who comes from a control systems and a systems engineering background, I think about this story a lot when I hear about the inevitability of advancing automation in technology systems. The fact remains that complex technology systems still require a multi-dimensional design process. And total automation itself is not inevitable, nor is it a desirable future for us all. When we are designing systems, especially systems impacting humans at scale, it's important that we distinguish between automation, autonomy, and agency. Automation is technology which reduces human intervention in processes. Autonomy is self-determination, the right of an individual to govern yourself and make independent decisions. What a concept. Agency is the capacity of exerting power and control. While these are all about control and power and the level of where control is held, they are fundamentally three separate concepts. A little over a year ago, Hillary Mason, co-founder and CEO of Hidden Door, the gaming company, shared a post on LinkedIn calling out the ways that the word agent was being thrown around in three entirely different ways. The first was used to address an architectural approach to chaining calls, which she referred to as 100 LLM calls in a trench coat. Jeremy is my Gen AI LLM detector today, so if you hear a squawking chicken in the front, that's the dying cry of the rubber chicken. Did take me to slide 26. I'm very excited about that. The second was when an agent was used as a unit of labor to sell automation software to replace humans. The third was when software was granted agency to act on behalf of other software or the user themselves. And so with this one example, and not to Hillary's fault, you can already see where concepts are being conflated based on who is in the room and what they're trying to sell. So let's talk a little bit more about a year later. How is this holding up now? So for definition one, the 100 LLMs in a trench coat, thank you. Agent in this sense is the approach of integrating Gen AI models and chained probabilistic processes into large-scale systems, and this continues to evolve. And the underlying architecture is changing. It's blooming new large-scale non-deterministic systems all around us, which is super fun. There's still a distinction in the types of reliability that we need. And so I want to focus here on the concept of when people get very excited about using things in prod and scaling them and moving them out into the world. I really like how Charity Majors quickly framed this architectural change in the terms of durable code versus disposable code. So in this article, she outlines what we already know. The cost of software was never what it took to write it. It's always been the cost of what we are willing to continually maintain, extend, migrate, understand its behavior, and fix it when it's broken. It was never just the code, and it is still very much the system, and who can keep that system online? Speaking of keeping those systems online, this brings us to definition number 2. When agents are and have been sold as a unit of labor to improve corporate productivity by decreasing the cost of paying humans to solve problems. This is my least favorite sales pitch. It gives automation for the sake of improving a human condition a terribly bad name. Because I love robots. I especially love robots that do the things I don't want to do. I am a big fan of automating the boring stuff. Thank you, Al. If it's dull, it's dirty, or it's dangerous, I don't want to do it. And I don't want humans to have to do it either. But the problem isn't about automation, and it's not even the evolving concept of agents. In the case of the agent will replace your human labor, we're already starting to see the restructuring of what it costs to build, deploy, and run agents. It turns out that things actually are sold in quantities of compute and storage. There's a quiet rehiring of people being hired back to fix the problems that were not able to be solved through automation, compute, and storage alone. It's not happening at the same scale, and it's not happening at the same places. This is very similar to how manufacturing changes impacted different kinds of factories across the United States, where things move in different places, and when they come back, they don't come back with the same number of jobs, they don't come back with the same kinds of skills, and they don't come back with the same kinds of systems. Things fundamentally do change. And the trade-offs will continue as the return on the investments that have already been made continue to be evaluated quarter to quarter. Definition 3, a program that does stuff with other programs, takes up a lot of space in the technology world most recently. Specifically, this is where an agent as a program does stuff with other programs, including stuff you didn't know it could or would do. And let's go back to the concept of agency and granting control. So many of the challenges in the didn't know it could do that stems from the conflation of the types of permissions, access, and underlying assumptions made about the kinds of actions these accounts will and should take. Standards and protocols expect humans to behave in a certain way, or want a certain level of agency over their interactions within a system. Likewise, machine accounts have baked-in assumptions. And then there's agents. They are not yet a consistent, standardized way to have these interactions without granting some weird combination of human or machine control. So instead, you get this weird thing, again, where they're conflated, where it becomes impossible to differentiate in log traces and metadata whether you're unpacking a human or a machine or an agent. And quite frankly, this is also somewhat not new. If you've ever tried to work with any kind of data from like large-scale version control systems, it's nearly impossible to tell when something was taken by a CI/CD or a bot versus when it was a human account based on how some of these logs are done. This is going to continue to scale the problems we feel now unless we radically change how we grant this new concept a unique tier of control, access, permission, and most importantly, observability. When you combine these three, again, you can see the problem is where automation is being combined with concepts of agency and access into systems at scale, while we are still defining the right level of controls, protocols, and standards without the units of labor necessary to build, maintain, deploy, and recover these systems from failure. So, how do we maintain autonomy in a world of accelerated automation at a global scale? I said this was about hope. In The Ironies of Automation by Lisanne Bainbridge, she describes the role of operators in systems where automation can take control, and the cost of that control in terms of system resilience and recovery when operators are designed out of the wrong stage of decision-making. So when automation, autonomy, and agency become conflated at a global scale, we get the pressure and the urgency to match the design of the systems being built to the edge of compute. But just like the Apollo lunar landing the Apollo lunar module, there will absolutely always be situations that we could not engineer, predict, or model, when the success of the moment will depend on the skills, knowledge, and experience of the people making the decision at just the right time. So rather than continue to automate every possible unit of labor, we must intentionally build processes to operate at human speed rather than push people to make a critical decision to meet the machine speed someone else sold. Right now, some of us have the opportunity to be agents of change. We're working in the field already of accelerated automation at scale. We can keep showing up. We can keep asking questions. We can challenge thin or unsupported assumptions. We can talk to each other and share what we've learned. We can hold blameless postmortems. It's still possible. We can learn from our mistakes and the mistakes of others. No exception to this is Benno Rice's recent talk at North Bay Python 2026 on the state of exception, where Benno kindly walks us all through a philosophical exploration about what happens when things go wrong, how we know they've gone wrong, and what do we do about it. And yet, regardless of tenure or years of experience, we're all facing professional uncertainty in a way that hasn't been experienced in decades. So how do you find agency in a world intent on moving forward, regardless of your own capacity and speed? We cannot individually or even collectively control for all the factors which impact the uncertainty we face and the pressures we feel. But we can find ways that we can work together to balance between scarcity, spaciousness, and the continuously predicted heat death of open source. You can't move from scarcity to spaciousness when you're burnt out. In their 2019 book, Burnout: The Secret to Unlocking the Stress Cycle, authors Nagoski and Nagoski address the differences between stress, burnout, the difference between the two, and how humans cycle through these states but can get stuck. And using science-based approaches, they identify specific interventions for how people can work through where they are to identify vectors of where power and control feel lost. This is identification of lost. This is not the solution to regain control, but it does provide guidance on how to move as an individual to a place where seeing beyond the immediate is more possible. You can't move from scarcity to spaciousness when your well-being is at risk. Much more personally and more beautifully than I could ever speak to, please watch Mark Gibbons' talk, Finding 2.0, which was presented at PyCon US 2025. Moving from scarcity to spaciousness is getting to a place where it is possible to ask, what needs to change with compassion, empathy, and self-compassion. So what needs to change? We need to be okay with bounding both the transactions and the interactions. Open still allows boundaries. Just because you publish a recipe does not mean people can just show up in your kitchen and demand cookies. It does not mean they get access to your home, your address, your front door, your attention, or your time. We won't be able to solve social problems with a different platform. We're going to have to fundamentally rethink how we extend invitations for ideas, conversations, consensus building, decision making, as well as the technology processes which host these. What needs to change? It's difficult to maintain continued empathy in spite of a world of spite. If we continue to bring empathy for each other and for someone new, we also need to maintain the challenging but important work of community governance, community moderation, and letting people know the playground rules. It is clear and kind to simply tell new people, we don't do that here. If we can't maintain or staff the systems that govern and moderate wider and more open communications, the boundaries will get smaller to a space that is manageable. Being more open takes more work. What needs to change? It's okay to do something small. Not everything needs to scale. Not every project needs to live forever. People change, technology changes, interests change, forks should come and go. You don't owe anyone your Git history, your PyPI package name, or your mailing list. When the trade-off comes between your own health, well-being, space, or weekend time, make that your choice, not someone else's dependency you didn't sign up for. What needs to change? Enough must actually be enough. The need can be endless, the resources are not. The demand can seem endless, the people are not. The license is free and open, the labor doesn't need to be. What needs to change? Fundamentally, in the society we live now, people need jobs. I can't solve this for everyone, but I'm going to do my best to help who I can, when I can, and whenever I can. I can sit down with a friend and learn about what they need, what they are looking for, and what they can't say yes to. I can ask other friends who is hiring, what it's like where they work, what the hiring process is like. I can be clear with people about what the hiring process is like where I work and what to expect. And if I can't help today, I can try again tomorrow, and the next, and the next. And I can ask everyone else who is in a position to help to do the same. What needs to change? Community cannot be maintained by static assumptions. What brings you here? What keeps you here? These are golden questions to help us understand where someone is coming from and where they find meaning in the space you are both in. When we are at a place where we feel more in control, capable of moving forward, connected and curious, this is where we can find space, not just for ourselves, but for each other. Last year, I walked into an empty room where I expected there to be a talk. I didn't have to bother Elaine. The door wasn't locked. But after waiting for a few minutes, the speaker came by and let the small group of people there know the talk had been moved to a later time and space to make room for a larger audience. He was kind enough to offer us a preview in case we couldn't make it later. This is how I stumbled into learning about blowing glass on the moon. The surface of the moon is covered in moon dust, or lunar regolith, which has a large concentrations of silica, one of the main components of glass. And when it comes time to building things in space, you need to use what's there when you can. Turns out, they don't just actually hand out samples of moon dust to people with wild ideas, and there's no testing in prod with this one. So you need to be able to recreate the surface of the moon, but here on Earth. Lunar regolith simulant is material synthesized from terrestrial sources to approximate different regions on the moon in order to approximate the chemical, mechanical, engineering, mineralogical, and particle size distribution properties. Part of the scientific challenge in recreating these simulants is that the surface of the moon is non-uniform, like any other body in space. The samples collected at different times have been tested, categorized, and somewhat consistent metadata to define their taxonomy to make it easier to have reproducible results. So what exactly is lunar regolith simulant primarily used for? Space systems are extremely expensive to send into their environment, so they go through as rigorous a testing process as teams responsible can dream up. For any system expected to be in contact with moon dust, Mars dust, or asteroid dust, they want to test against that dust. This means you need dust to test against, and you want that dust to be as close to the real thing as possible. If you're testing a theory for material science viability on lunar surfaces to build human habitats, you absolutely want to know you've tested as close to the real material as possible. That's actually what blowing glass on the moon was all about. Testing the possibility of blowing glass structures on the lunar surface. And who better to figure out whether you can blow glass on the moon using lunar regolith than a glass artist who has spent a career making worlds out of sand? Josh Simpson, a glass artist, and his collaborator, architect Martin Bermudez of Skyports LLC, were chosen for their lunar glass structures, or LUNGS project, from hundreds of applicants for funding in NASA's Innovative Advanced Concepts, or the NIAC program. The Lunar Glass Structures, or LUNGS project, asks the question, in the moon's vacuum and low gravity, could molten glass be blown or inflated into enclosed high-strength structures able to shield astronauts from radiation, micrometeorites, and extreme temperature swings? And that's who was kindly walking me through his not yet scheduled talk. Josh Simpson, the glass artist, who with his research partner and collaborator actually did figure out how to turn synthetic lunar regolith into a structure of blown glass. This is his TED Talk, actually, where he walks you through it. It was from January, so if you want to catch that, it's fascinating. It's already obvious I'm fascinated by space and science. And what humans create when we come together. And I will tell you that all I really remember from my conversation with Josh is that this is what hope feels like. Because hope is what it feels like when every role and every contribution can have meaning as part of a community and a network who are all working collectively towards the same goals. Hope is what it feels like when we stay here because we do believe in community, collectively building for a future we may never see or directly benefit from. There's no ROI on hope. Hope is what it feels like when we build people up, when we have champions, not just heroes, when we have team captains and partners, not just solo artists, when we build people up to take on what's next, and then we step back to let them shine. Hope is what it feels like when we believe with the optimism of every author, an organizer, and volunteer everywhere that at least one other person in the world might find a kernel of our work, and that one moment will make that work worthwhile. Hope is what it feels like when we can catch a glimpse at even one of those moments. And as someone who has a tiny window into one evolving engineer and Pythonista, please grant me the space to assure you these moments exist because of you, and to thank every person here from the bottom of my heart. For now, we're here in a moment in both time and space. That moment will change. The time and the age we are in will change. The space we are in will change. And while change may be inevitable, a complete lack of autonomy and agency in the face of automation is neither inevitable nor is it necessary. Equal autonomy has never been granted or given, but it can be collectively won and defended. So we can stay here in this cycle, or we can find a new balance for human-machine systems at a global scale. We can stay here, focused only on the now or the next quarter, or we can do the work individually, collectively, and intentionally to be capable of moving to what is beyond. We can stay here, or we can find the space and the wonder within and without, the wonder in ourselves, the wonder of the world, and the wonder of each other. And we can all build the future we may never see, but we choose every day to believe is possible. Thank you.